All right, in this video, I'm just going to go ahead and do the first and second derivative of all the examples that we're going to go back and do this curve sketching for. That way, when we get ready to do the graphing, we don't have to sit there and do all the work on the derivatives, okay? All right, so for the first one, I'm going to do the derivative using the factored form, even though it looks like it'd be easier to use the polynomial. And that's because I need to be able to solve what causes f prime of x to equal 0. So if I use the original problem, I'll get 4x to the third, so I'll get a cubic function, and then I won't be able to get it in factored form. So I'm just going to use the product rule on this. So I'm going to do the first times the derivative of the second plus the derivative of the first times the second as is. All right, now notice there's an x minus 4 to the second power that I can factor out. When I do, what's left is 3x plus 1 times another x minus 4. So that's going to give me x minus 4 to the second, and then that'd be 3x plus 1x, that's 4x minus 4. So let me get the 4 factored out. I'll put it out in front, and then there'd be an x minus 1 left. So I have a 4, an x minus 1, and an x minus 4 squared, right? And then when I do f double prime, I think for that one, that you could have just done the first and second derivative of f, or I can go ahead and take this. Let me write it in this order. Okay, so I'm going to do the second derivative looking at where I wound up over here. So I'm going to do the first times the derivative of the second plus the derivative of the first, which would be 4, times the second as is. Okay. I may space this a little more. Oh well. Let me see if I could just get that spaced. Get us a little more room here. Okay, we put a little more space here and here. All right, so on this one, I'm noticing that I've got the x minus 4 I can factor out, and I can also take out a 4. So I'm going to take out a 4 and an x minus 4. See what's left. All right, so I'm going to have an x minus 1 with a 2. Let me put the 2 first. I'm going to have a 2 times x minus 1 left. And then I'm going to factor out the 4 and one of the x minus 4. So I'll have an x minus 4 left there. So that's 4 times x minus 4. And then this is 2x minus 2 plus x minus 4. So that's going to be 3x minus 6. And if I pull the 3 out and put it with that 4 right there, that'll get me 12. X minus 4, x minus 2. So there's your first derivative in factored form, and there's your second derivative. All right, so let me go through several of these, trying to get the derivatives out of the way so that we don't have to focus on doing that while we're trying to graph. So f prime of x, you'd bring the 3 down, multiply it by 1/3, and then it would be x to the second minus 400, and that would be just x squared minus 400. And the second derivative would just be 2x. Okay, that one was pretty quick. All right, on this one, I'm going to do the low d high thing. So on f prime, I'm going to be doing the low times the derivative of the high minus the high. Oops, let me put that. Minus the high times the derivative of the low over the low. Darn it. Try that again. Okay, so low derivative of the high minus the high times the derivative of the low. All of that over the low squared. Okay, so now this one, I think I'll just go ahead rather than the factor thing, since that's just a monomial, I'll just distribute and I'll work that out. So that's going to be 30x to the fourth minus 30x squared minus 20x to the fourth over x squared minus 1 squared. Gosh, I don't remember that. So that's going to be 10x to the fourth minus 30x squared over x squared minus 1 squared. Okay, and then I could write it in factored form as 10x squared times x squared minus 3. Okay, so that's the first derivative in factored form right there. Okay, now let me move this one out of the way. Okay, let's work on the second derivative. I'm going to look at that finished product over there. Okay, this one's going to be kind of lengthy. I think I'll actually look at that when I do it. So I'm going to do low derivative of the high minus the high derivative of the low. Don't forget to do the chain rule. All of that over the low function squared. Okay, and then you have to clean it up. So here, let me just leave the first one as is for a minute. It's not in too bad shape. It'll be easy to see what to factor. But this one's kind of messy, so I'm going to look at it. So that's 2 times 2 is 4x times x squared minus 1 times that 10x to the fourth minus 30x squared. And the denominator would be x squared minus 1 to the fourth. All right, now one thing I notice is there's x squared minus 1 here, here, and here. So I can knock out one of those. So this will be down to 1, this will be down completely, and this will be down to 3. All right, and then I'm going to look at what I have after that. I'm going to look inside here. I see I can at least take out 10. So from here I can take out a 20x, and I can get 20x out of the other one as well. All right, so this is going to equal 20x. Then I'm going to have an x squared minus 1. And then inside there, that'll leave me with 2x squared minus 3. Okay. So that's that part. And then if I take a 20x from this area, remember, well, it might help if I work that out up here. So this up here is a 4x times that. So that's 4x times 10. That's 40x to the fifth. And this minus goes there. So that's a minus 40x to the fifth. And then this negative and that negative would be positive 120x to the third. So when you factor out a 20x out of there, you're going to have minus 2x to the fourth. And then you're going to have plus 6x squared. And then all of that's over the x squared minus 1 to the third. So you see the derivative part itself can take a long time. So I thought maybe if we just do all the derivatives and get them out of the way, and then come back and do the curve sketching. Okay, so inside here, let me go ahead and FOIL this. That would be 2x to the fourth minus 3x squared minus 2x squared plus 3. And then we have minus 2x to the fourth plus 6x squared. So the 2x to the fourth will go. This will be minus 5x squared plus 6x squared. So that'll be an x squared. Let me get that moved up a little bit. Okay, so I have a 20x. And then I have minus 5 plus 6 is 1x squared plus 3. And then I have the x squared minus 1 to the third power. Okay. All right, so that's for number 3. All right, so let's go ahead and take a look at number 4. Okay. So here, you might want to remember that that's 4 minus x squared to the 1/2 power. Let me get a little room. When I do f prime, that's going to be 1/2 4 minus x squared to the negative 1/2 times negative 2x. Don't forget to do the chain rule. 1/2 and negative 2 would be negative 1. So this is negative x over 4 minus x squared to the 1/2 power. Or you can leave it negative x times 4 minus x squared to the negative 1/2 power. Okay, either of those. The 1/2 and the 2 would cancel out. Okay. Let me write it here. There we go. Okay. All right, so now let me do the second derivative down here. All right, this one takes a little simplifying. All right, I'm going to look here. So I'm going to do first times the derivative of the second, which would be negative 1/2, 4 minus x, 4 minus, let me erase. There we go. 4 minus x squared to the minus 3/2, because you subtract 1 from that. Then don't forget to multiply that by the derivative of the inside, which would be negative 2x. So that's first times derivative of the second. Okay. And then I have to do plus second times the derivative of the first, which is negative 1. All right, I'm going to slightly clean these up, and then we'll see if we can figure out what it turns into. So that makes an x squared. Those would become 1. So it's negative x squared times the 4 minus x squared to the negative 3/2. And then it's minus 4 minus x squared to the negative 1/2. Now, when you do the whole factoring out, you take out the one with the smallest exponent, and negative 3/2 is actually smaller. So if you take that out, you're going to have a negative x squared left there. It's going to be plus, because you already took out a negative. And then when you take what this would have to get distributed to inside here, in order to become a negative 1/2, is you'd have to have the first power on that. So you see that becomes 4 minus x squared to the negative 3/2. And this would be negative x squared plus 4 minus x squared. I think that was supposed to cancel out. Let me look again. So I took out 4 minus x squared. Let me double check. Let me just go back. I'm trying to do the second derivative of number 4. Okay, so the first derivative was negative x, and then the 4 minus x squared to the 1/2 power. Okay. All right, so then I did first times the derivative of the second, which is negative 1/2, 4 minus x squared to the negative 3/2 times negative 2x. And then I'm going to do plus the second times the derivative of the first. Okay, so that was good so far. Then I took this negative x. Okay, so this, and this would make it negative. It'd be x squared, and then 4 minus x squared to the negative 3/2. Then here, that would leave you with, then you'd have minus. Okay, so that's good so far. All right, so I'm factoring out 4 minus x squared to the negative 3/2. And that leaves me with a negative x squared. Oh, there's a minus right there. Leaves me with a negative x squared. And then a minus right here. 4 minus x squared. So that would become negative 4 plus x squared. So the x squareds are gone, and right there you just have negative 4. Okay, so this is really negative 4 over 4 minus x squared to the 3/2 power. Okay. All right. That was probably the longest one. Let me do this. Undo, undo. There we go. Okay. All right, so let's do this one. This one's not so bad. Okay, so for the first derivative, derivative of e to the something is e to the something, but you got to do the chain rule. So you're going to do the derivative of negative x squared, which would be negative 2x. Okay. Okay. And so that winds up equaling negative 2x e to the negative x squared. Okay, now when I do f double prime, I'm going to have to use the product rule. I'm going to separate it like this. And the derivative of, so I'm going to do the first times the derivative of the second function. And the derivative of that second function is what we just got. So it's negative 2x e to the negative x squared again, plus the derivative of the first times the second. Okay. Right, and then a lot of times we'll just factor out everything we can. You might go one more step, simplifying before you do your factoring. That's really minus. Okay, so now I'm noticing that there's a 2 and an x and an e to the negative x squared. Let me check, let me look again. All right, so I did derivative of this was e to the negative x squared times negative 2x. Which would be negative 2x e to the negative x squared. Okay, then I did first times the derivative of the second plus Let me do this part again. Okay, so this was the first function times the derivative of the second function plus the second function, there we go, times the derivative of the first. That's better. Now let me see what that turns out to be. Always have to check these. It's so easy to mess up. So this would be -4. That'd be positive 4x squared e to the negative x squared minus 2e to the negative x squared. So if I factor out the 2 and the e to the negative x squared, I'll have a 2x minus 1. Okay. All right, so that's number 5. All right, so let's look at number 6 and number 7, and then we'll be through with the derivative part. Okay, so on number 6, all right, this is a product rule problem, so it'll be first times the derivative of the second, which is negative sine x, plus the second times the derivative of the first, which is also cosine x. So this is negative sine squared x, but then plus cosine squared x. All right, and because it's squared on these, what I could do is replace either the cosine or the sine, because this very common identity right here. We know that cosine squared x plus sine squared x equals 1, so we can use this identity to make a substitution right here. So right in place of that, I'm going to put 1 minus sine x squared. So right here, if I put 1 minus sine, I said it wrong, 1 minus sine squared x. If I put that right there, and then I had negative sine squared x here, then this becomes 1 minus 2 sine squared x for the first derivative. Okay. When I get ready to do the second derivative, the derivative of 1 is 0. The derivative of this would be, don't forget, this is really negative 2 sine of x squared. So you have to use the power rule and the chain rule. So that's going to be negative 4 sine x to the first. So I brought the 2 down in front, got the negative 4 sine x to the first, and then the derivative of sine is cosine. And so you wind up with just negative 4 sine x cosine x. That's the second derivative. Right, and then finally on number 7, first derivative would equal 1 over x squared plus 1 times the derivative of the inside part. So it's 2x over x squared plus 1. And then second derivative would be low times the derivative of the high minus the high times the derivative of the low over the low squared. Okay. All right, so that's going to be 2x squared plus 2 minus 4x squared over x squared plus 1 quantity squared. Okay, so that's going to be negative 2x squared plus 2 over x squared plus 1 quantity squared. Okay. All right, and if I did it in factored form, I might take out a negative 2. I'd have x squared minus 1 and then x squared plus 1 quantity squared. So either of those is okay. Okay, so this video, I just wanted to do all the derivatives and get those out of the way. So go ahead and get ready to do the curve sketching.